Okay, so let's start where we stopped. We said that in the previous video that the equation of this curve is a to the power x. Now we want to find the value of a, and the best way to find the value of a is to use what we started from, which is this line, because this is where we started from. We wanted to use this line, bend it to make that bent line of ours, basically bend this point down and bend this point up. So since we started with this line, we want to somehow capture the essence of this line in this curve, a to the power x, and that is going to help us determine the value of a. Now let's focus on just this line. So if you look at this line carefully, it is at an angle of 45 degrees. It's going through the origin, and it's kind of symmetric around, it's exactly symmetric around y-axis and x-axis. So you can kind of visualize by now that the slope of the line is 1. And if you really need help in understanding that, then here it is. If I draw this tiny triangle here, then this height by this width is 1, because this is symmetric around y and x, so the y and the x are going to be equal. So the slope is 1, and it's passing through the origin. So the value of b is 0, because b is the vertical height from the origin, but it is 0 in this case. So this line is nothing but the slope itself, right? So this line is equivalent to having slope equal to 1, and we want to capture that slope in this curve. And the best way to capture that slope is to use the most important point in this curve, which is this. This is the most important point because we did a lot of operations around this point. We reciprocated it and did a bunch of things. So this point is very important. So we want to capture the slope of 1 at that point, and the way to do that is by drawing a tiny tangent there and enforcing that the slope of this tangent be 1. So if you do that, then we're capturing the essence of this line in this entire curve, because this is the important point. So we are enforcing that the slope of this tangent is 1. Now the moment we do that, we get a very specific value of a, and that specific value of a is e. Now why this e can be talked about in another video, but for now just take it as a given that the moment the slope becomes 1 at that point, the value of a becomes e. The moment the value of a becomes e, the equation of our sweet looking curve becomes e to the power x, which was previously a to the power x. Now this is e to the power x, and we are going to reciprocate this, and the moment we reciprocate this, it will be e to the power minus x. And if you remember, the reciprocation of this is going to look as if we are negating x, and that is what is reflected in this as well, right? So the reciprocation is e to the power minus x, which is basically the same as flipping the x-axis with respect to the previous curve, e to the power x. Now I'm going to shift this particular curve upwards, okay, and let us see what happens. I'm going to shift it upwards by 1. So basically I'm going to add 1 to each and every point of this curve and shift it upwards. So the equation of that becomes e to the power minus x plus 1. And if you see, this becomes the x-axis, this becomes the y equal to 1 line, and this is on top of this. So it's as good as shifting the entire thing up by 1, adding 1 to each and every point of this curve. So now you can probably see that I'm trying to rebuild where we left from a couple of videos ago, where this was the reciprocal of our beautiful looking bent line. So if we reciprocate this along this y equals 1, we are actually going to get a bent line. and the reciprocation of this is going to be nothing but 1 divided by that. So 1 divided by that, which is here, becomes the equation of our bent line. So now you see how we got to this bent line from the straight line, capturing the essence of the straight line and then leading to our bent line. This is the end of this video. It's a very interesting visualization how we come to this line from that straight line. In the next video, we're going to talk about other things about logistic regression, and in some other video we're going to talk about why that a equal to e was there when the slope at that point was 1.